Today's lecture, From GIS to Civil 3D, is going to go through a series of discussions and practical exercises similar to last week. This lecture builds directly upon the past two lectures that we've had for this course, and it serves as the capstone of everything that we've done so far this semester. So today we're going to be going over importing and preparing GIS data in Civil 3D, annotating and refining boundary evidence in Civil 3D, creating surfaces and site context from evidence, and preparing for presentation and final deliverables. And then we're going to talk briefly about how everything this semester has come together with this final exercise. Again, this lecture serves as the final lecture in the final lab for this course. Good luck. This lecture is the final stage of our course, the point where your courthouse research, CAD parcel data, and GIS analysis all converge into a unified, design-ready model. Last week we focused on locating and assembling record evidence, building your parcel boundary inside ArcGIS Pro, and validating that geometry against CAD data. Today, we're moving into Autodesk Civil 3D, the environment where surveyors and engineers coexist. This is where your evidence becomes infrastructure, where legal geometry transforms into the foundation for design, subdivision planning, or site development. Now, this lecture isn't about memorizing commands or tools. You've already seen many of these in your labs. Instead, it's about understanding the why behind the process. Why would we bring GIS data into Civil 3D? Why coordinate systems must align, and why boundary evidence, once digitized, must still honor its legal intent. Back in Lecture 7, we talked about how surveyors benefit from learning design software like Civil 3D. This lecture is the proof of that idea. By mastering this workflow, you begin to become more than a technician. You start the path to a professional capable of bridging disciplines: law, design, and spatial data management. Before we begin the practical portion, I want to emphasize how this connects to everything you've done across the semester. All the way back in Lecture 1, we looked to the past to help us understand the history of drafting and surveying. Through Lectures 2 and 3, we emphasized fundamental concepts and how to use a CAD program like Civil 3D. In Lecture 4, we first introduced plats and the legal frameworks that govern surveying in practice. Through Lectures 5 and 6, you received the foundations for understanding boundary evidence and site surveys. Lecture 7 introduced design integration. Lecture 9 explored digital land systems and the cadastre. And Lecture 10 demonstrated how GIS can host and manipulate your record evidence. And all that as well, we must include in Lecture 8, we had Mr. Gary Kent, who gave us our lecture on ALTA or land title surveys. But coming together now, in Lecture 11, it all comes together: evidence, technology, and presentation, into a single professional workflow. So next, we'll begin Practical Exercise 1, where we'll import your GIS data into Civil 3D and prepare your base drawing for annotation and refinement. Now that your boundary sketch is complete and validated in ArcGIS Pro, it's time to bring that work into Autodesk Civil 3D. This step bridges the analytical worlds of GIS with the drafting precision of design software. You'll be importing your data, configuring coordinate systems, and preparing your base drawing for the work that follows. All right, so this will be Practical Exercise 1, Importing and Preparing GIS Data. First thing you're going to need to do is open Civil 3D and start a new drawing. Then in your tool space, go over to your settings, and where you see your drawing listed at the top, right-click on that and hit Edit Draw Settings. There, make sure you're under Unit and Zone. And then what we're going to do is we're going to change our zone category to USA, Texas. That's going to give us access to the available coordinate systems in that area. So under the Available Coordinate Systems dropdown, go ahead and look for NAD 83 Texas State Plains south zone US foot. That's going to go ahead and make sure that we have our coordinate system set up for our drawing. All right, once you've got that done, go ahead in the command bar, go ahead and type in map import. That's going to open up your ability to import your shape file into your drawing. So go ahead and navigate to where the week 12 lab data was downloaded, and then go ahead and look for Kogo lines and import your Kogo lines data. You're going to notice right here, you're going to see your current drawing coordinate system listed as TX83-SF, and you're going to say the same thing on your input coordinate system. Don't check the import polygons as closed lines box. Once you've confirmed that, go ahead and click OK. Now, in your drawing space, go ahead and move over and click on Zoom Extents. It's going to bring you to focus in on the Kogo drawing that we did last week in ArcGIS Pro. You can confirm all of the different lines that we have in here from last week. So now go back into the Prospector tab, and under Points, click on Create Points, and then the last option, select Import Points. Again, there's going to be a point data set that was included in your week 12 lab data. So go ahead and go to that, import those. They're going to be PENZD. And once you have your points loaded, it'll look a little bit like this. You'll be able to check over here to see you've got about 99 points that were brought in. And these points are supposed to simulate field data that we would have collected on-prem if we were doing this survey. So go ahead and review the different points, their raw descriptions, to try to get an idea of the type of information that we collected in the field. So we have ground shots, we have some trees, we do have our found corners, the building that's going to be on the lot. Once you're done with that, go over to point groups and then right click, hit new, and let's create a point group for our found corners. Go ahead and stylize them as you see fit. I'm going to use the iron pin symbology. I'm going to leave it as the point number elevation description for the label. And our raw descriptions here are going to be FND star. So all of our found corners. Hit apply and OK. And now you can see all of the found corners that we recovered. So that was from our starting point, our point of beginning, going all the way back over to our actual lot that we were surveying. Under all points, I want you to go ahead and change your point style and your point label style to none. That way we can look at just our found corners for the time being. I want you to take a moment to try to review the accuracy of some of these found corners based on our Kogo. So what our Kogo would have done, it would have given us the ability to go out in the field with our GPS receivers and have an idea of where these corners are supposed to be. The Kogo does not represent the actual location of our corners. It just gives us a basis as we start to explore in the field where these corners may be. So what I'm doing right here is I'm actually adjusting the marker a little bit to ensure that I can have a cross section go into the exact middle. It'll make it a little bit easier to compare with our Kogo lines. Because you saw before, it was just a circle with that line relatively within it. So that's an ideal of accuracy, which is great. But now we can see here a lot more clearly where our symbology now marks the dead center and our Kogo lines don't exactly meet it. And that's to be expected. That's what you're going to see almost every single time when you do this type of work. You're going to set something up, you're going to go out to recover monumentation, and it's not going to be exactly the same as your design. And that's because the real world is imperfect, and our design environments, don't ever properly reflect reality. But that's all you need to do for exercise 1. Go ahead and save this, and if you want, leave it open. We're going to be using this exact same drawing again for part 2. Let's pause here and connect what you just did to the bigger picture. Back in Lecture 10, we used ArcGIS Pro to validate boundaries in a spatial environment. But GIS, by design, is analytical. It's built for managing data relationships, not producing precision deliverables. Civil 3D, on the other hand, is a design environment. It requires that geometry not only be accurate, but also communicable. Engineers, planners, and surveyors must all be able to use it, understand it, and trace it back to evidence. In Lecture 7, we discussed how learning Civil 3D gives surveyors a broader professional reach, the ability to participate directly in the design conversation. What you've done here is exactly that. You've taken verified, legally grounded evidence and introduced it into a space where it can inform design decisions. Every project that begins with a survey ends up here, in some form or another. The subdivision plat, the road layout, the site grading plan, they all originate from a single set of boundary evidence, just like yours. Now that your parcel geometry has been successfully imported into Civil 3D, it's time to transition from pure geometry to annotated evidence. This section focuses on refining your imported line work, add bearings, distances, and labels, and preparing your drawing so it communicates clearly and professionally. This is where the evidence you built in GIS begins to take on the polish and precision expected in deliverables like plats, easement exhibits, or engineering base maps. All right, so this is practical exercise 2, annotating and refining boundary evidence. So go ahead and open up your drawing. We still have our found corners and our Kogo lines from week 11 added in here. The first thing that we're going to want to do is we're going to use our 4 found corners and create a new parcel to represent that lot 19. So go ahead and open up your parcel creation tools. I'm going to use fixed line 2 points. And you see here, actually, the first thing it tells me is it wants to create a default site. So instead of that, close the parcel creation tools, go into your prospector tab, scroll down to sites, right click, pick new, and then go ahead and create a site called Cardinalis. Go ahead and hit apply and OK. And you'll see here now we have a fresh, clean, empty site for us to work with. So let's go ahead and go back into our parcel creation tools, and we're going to go ahead and create that parcel for lot 19. So again, I'm going to do the fixed line between 2 points. For my area label style, I'm going to use name, area, and perimeter. However, the default, as we know, is going to be acres for our area. I'm going to change that to square feet. This isn't a very large lot, so doing it in acres isn't going to be useful to our client. So set our unit to square foot and insert that to override the acres, and then change the AC unit denotation to SF for square feet. Go ahead and click OK. You can see in the preview, it's trying to put those borders and masks on our labels. So let's hit the visibility for our border and our background mask as false. The background mask we haven't talked about too much before, but it will play a role when we start adding our base maps later. Let's go ahead and hit apply and OK. And then I'm also going to turn on automatically add segment labels. So I want to go ahead and have my bearing over distance labels generated as soon as my parcel is completed. Leave the rest of the layers the same. Go ahead and click OK. And let's start at point 1068. And let's draw out this parcel based on our found corners. So 1068 to 1069, 1069 to 1070, 1070 to 1071, then 1071 back to 1068, our effective point of beginning. For this parcel, at least. So go ahead and exit the parcel creation tool, and you'll see our labels get automatically generated. So clearly the area, the property name area perimeter label is a bit large. So we're actually going to go ahead and edit that style so that that text isn't so large on us. So you can get to editing your label style a lot of different ways. I'm just going to right click on the area label itself in the drawing space And then I'm going to go down to Edit Area Selection Label Style. I'm going to edit it. And then under Text, under the Layout portion, I'm going to change it from 0.15 inches to 0.1 inches. Now, you'll change heights several times as we go through the project, just for the sake of visibility, of clarity. But that's all I'm going to do for right now. Just change it to 0.1. So go back into your parcel properties. You're going to see we have under analysis, we have our essentially our legal description written out here, all of our different segments. So that's another quick way to check that and assess it. But actually, close that out just a little bit too quickly. You see we have it named as property 1, which is just the default. However, we know this is lot 19, not property 1. Since we're not doing a whole subdivision here, I'm just going to uncheck the Use Name Template and Parcel Style box under Information and change my name to Lot 19. It's just a one-off parcel, so it's not that big of a deal to manually label it versus systematically label it. Back under Point Groups, let's go ahead and create a new point group to start denoting some of the different bits of evidence, the information features that we recorded during our survey. So you can do this for quite a few of them. Go ahead and you can copy exactly the groups I'm making. You can make your own. When I did my tree labels here, I actually think they're rather distracting to look at. They're kind of large. So what I'm going to do is I'm actually going to go in and I want to edit that tree symbology. So under display, I'm going to go ahead and change its color. Instead of being by layer, I'm going to give it a custom color that I think isn't going to clash as much with the labels that I have. So I'm going to kind of just do this like light dusty sage green here. And then I'm going to copy this RGB color under true color, so I can just set the label to be exactly the same color. You don't have to pick these colors exactly. It's not that big of a deal. It's just kind of what I'm doing. So I think that's a little bit better aesthetically. However, they're still a bit large. So I'm going to go ahead and edit that label one more time to adjust its size. So under the marker tab, you can see that it's just being drawn in absolute units. I'm just going to make it half that size, and that should be a lot workable for now. Maybe I'll change it in my final deliverable, but for now, this is good enough for me to still see it, recognize what it is, and work with all my other features around it. So let's go ahead and create a few more different point groups to sort out some of our different features. We recovered manholes, which is something that's going to be very common whenever you do these types of surveys. Always make sure you shoot in things like manholes, fire hydrants, things like that. I didn't include a fire hydrant in this data set. I should have, because that's something that's relevant. It's a insurance break if you have a fire hydrant within at least 500 feet of your home. It makes a very large difference on the cost of your homeowner's insurance. So little details like that can be useful and relevant to homeowners. I went ahead and just referred to everything as a storm drain manhole. I didn't specify if any of them were storm drains or sanitary sewers. It wasn't included in this data set, but if you were actually doing this work, that's the kind of information that you would be including as well. You'd also want to have 411 come out before you go and do your survey, and they would be able to mark any underground utilities that have already been laid. So I'm not talking about denoting the easements. That responsibility still lies with us, but the actual utilities that can be placed underground. 411 or 811, 811, not 411, sorry. 811, call before you dig. They're the ones that are going to denote that specific information. So for my utility markers, again, utility easements, they're not points, they are lines. However, we capture our information as points. So I'm just going to give them a relatively generic marker symbology right now, so that when I go in to add my line work, it's going to be easy enough to identify them and know what I'm looking at. So we have underground utilities, power poles, and overhead power lines all included in this site. I could turn on the descriptions for my point labels if I wanted. Um, However, I'm familiar with what's what, so I'm just going to go ahead and mark them with their elevations and work from there. Even the elevations aren't really necessary at this point. But let's go ahead and draw some of those lines for our utilities to denote where they exist. They don't need specific elevations or spatial references outside of their where they horizontally exist. Again, these are subsurface restrictions or arbitrary restrictions, like the yard restriction that's at the front of the property. Our overhead power line, again, that's going to be something that's running through the backyard. So we are going to want to denote that as well. I did capture the poles on each end there. That stretch is entirely too far to properly mimic reality. I'm sure some of you were able to discern that, but when I was just putting together the sample data set, that's just where it ended up. So, and again, there is that one power up pole in the backyard as well. And then, very importantly, let's go ahead and create our building point group. We're going to specifically want to denote that information here. Again, that raw description is BLDG. I'll hit the star, apply, and OK. Now we see we have those popping up. I just did very simple points. And what we're doing here, and what I'm going to do is I'm actually going to go ahead and draw out this polygon. You see I used that dot point, and it goes right over that abandoned easement from the city. So I'm actually having a really difficult time finding it. You can see when I hover over where it tries to snap, it's giving me an apparent intersection, not the actual point that exists there. So I'm going to go back into my building point group, and I'm going to adjust that point style from basic to standard. That's going to make it easier for me to snap to and identify the locations. And then I'll delete this one feature line that I did draw. I'm going to redo it as a polyline. This is going to help give me an actual polygon for the building whose corners we shot in. For those of you who think, oh, homes aren't truly this square. Yes, they are. Many homes are this square. There's not a lot of character sometimes to their exteriors. So that's all we're really looking at here. We've now got our building outlined. I'm going to go ahead and apply a fill to it, specifically just to this one object. You don't have to apply a fill. I'm going to because it helps me just identify better that there's a structure there or that there's a solid object in this location. So you can see by default, it's going to load up just as a solid white mass. I'm going to go ahead and adjust that hatch though. So I don't want it to be a solid block. I'm going to go ahead and apply a cross hatch here by default. You can see here, even when I set the hatch, it's still just looking like a solid mass. And the problem with that is it is a, I don't want to change the border. The problem with that is that it's just, the spacing is too close together. So we need to adjust it. Let me get out of here. And then the scale for our hatches is going to be right over here under properties. Change this from 1 if you want. I'm going to say 25, maybe 50. Pick whatever you think works best for you. Again, you don't have to put a hatched fill in it. I just like to do it. We haven't gone over hatches and what you should specifically use. I'm doing dashed hatches probably here, but what would probably make the most sense is a concrete hatch because what's underneath this house? A concrete foundation. But again, this is just for reference at the moment, so I'm going to go ahead and throw that in there. Now it's easy for me to identify specifically where that building is. And I want to go through, I'm going to select all of my easement lines. I'm going to go into their properties, and I'm going to actually adjust their line type as well, as the line type and the color. That way it can be more clearly denoted specifically that these are easements. We don't want everything to be the same color. One, that's just a visual headache to look at. But it's also just going to make it faster to interpret the drawing that we're looking at when we add a little bit more variety to it. There are standard colors and line types that get used for everything. It's not something that I'm enforcing right here. So, you're going to have the aesthetic authority on what you want your final drawing to look like. It doesn't need to be the exact same colors and line types as mine. Just make sure that it is readable. That's the key here. The reason why I don't want to enforce specific designs is just because every company, like I've said in past lectures, is going to have their own standards for how they do everything. So trying to force you to learn my way in this exercise isn't really going to be practical going forward in your careers. So find out what works for you. Make sure that you can find things that are readable, easy to differentiate each other, using different line types for my underground or my arbitrary easements from my overhead easements. However, I'm keeping them all the same color to represent either utilities or easements. But again, I want to know what's overhead, what's underground. So with that pretty much wraps up exercise 2. Closing out that practical exercise, let's take a moment to pause and reflect on what we've just done. Up until this point, every operation you've performed, from courthouse research to GIS validation, was about assembling evidence. What you're doing now is communicating it. Back in Lecture 5, we had emphasized that a surveyor's credibility rests on the clarity of their work, both in their reasoning and their representation. The labels you just applied are more than numbers, they're statements of fact. Each bearing and distance tells a story about how the surveyor interpreted the record and where they found agreement between text, monument, and geometry. Similarly, in Lecture 7, we discussed how engineers rely on survey data as their starting point. This annotated parcel is what they see first. It is the reference frame for every design decision that follows, a literal and symbolic foundation. So by taking the time to verify and label your geometry, you're not just making it look nice, you're establishing the chain of evidence that connects your work back to legal reality, the through line of everything we've studied since Lecture 1. Now that your boundary is annotated and refined, we'll take the next step in completing your project, building site context around your parcel. This step moves beyond the boundary itself and into how that boundary interacts with the terrain and nearby features. Just like we've done throughout this course, the focus remains on accuracy, interpretation, and clarity, not on excessive modeling. All right, this is practical exercise 3, creating surfaces and site context. So again, go ahead and open your drawing from exercise 2. And the first thing, if you haven't already, go ahead and create a point group from your ground shots. So we want to start visualizing these now against the rest of our drawing. So I'm going to go ahead and name it GS. I'm going to set its point style to basic. And I'm going to use the elevation only. And that raw description is just going to be GS star. Go ahead and hit apply and OK. And then now you can see on our drawing we have all of our ground shots listed. We'll see all those different elevations. So this is going to be foundational for creating our surface. So under your create section, go ahead and hit surfaces, create surface. We're just going to make a basic tin surface. We can leave its name as the default, but let's change our style from contours 2 and 10 feet to 1 and 5 feet. Go ahead and update that render material as well. You just leave it by block. So once you have those settings done, go ahead and click OK. You'll notice nothing changes on our screen. And that's because while we've created a surface, we haven't defined the points that it's going to use. So expand your surface definition under point groups, right-click it and hit add, and then go ahead and add your GS points group. Hit apply and OK, and then you should immediately see your contours generate. If you don't, go ahead and just type in regen and enter in the command line, and that'll go ahead and bring them up for you. So one of the things here, and I'm going to go ahead and turn off the visualization for the GS points right now since we have our contours going. One of the things we notice is we have a pretty steady grade going across our entire project. From this site, I'm not sure if it adds too much context for us, too much relevant information for our end user. So again, we have our 1 to 5 foot intervals. We could make it smaller, but I just am not sold on the idea that this is going to be a necessary visualization for our client. So what I would recommend doing in an instant like this is I'm actually going to I'm going to go and pull this surface off of my final plat. I wouldn't include it in the plat itself, but I would include my max and min elevations as part of my general notes. I would include it in my survey report. I would provide the slope information across our entire lot. That's going to give our client the ability to understand, hey, are there any major changes? No, I could see right here. It's a steady slope. It's not a lot that's gone on. It's nothing I need to worry about. We'd also have something, especially in an area in Nueces County, we'd have an elevation certificate because they're going to need to know their floodplain rating. So if we were to create a separate map just for the elevation certificate, maybe we'd put these contours on here. We'd denote the high and low points. We would denote the slope directions, as well as what the floodplain zone is for this specific area. I know from experience, it's Zone X. In case you weren't able to guess from the legal descriptions, I used to live here. So I'm going to go ahead and delete that surface, and that's just going to clean up our drawing, because at the end of the day, what this survey is supposed to be representing is a title survey for a home sale. They need to know the boundary. They need to know the easement restrictions in the corners. We're not going to go through an entire ALTA for this practice, but what it is we are going to go through plenty of detail just for this specific lot. So again, we've got our lot 19 drawn up here. We've removed that surface for the sake of readability. But I'll tell you what, if any of you want to go through the process of including your contours and applying an appropriate surface mask around the building, I'll go ahead and give y'all a bonus 10 points on your final deliverable. We haven't gone over surface mask specifically, so that's a great opportunity for you to earn 10 bonus points on this assignment. At this point, take a moment to zoom out and reflect on what your drawing now represents. It's more than a boundary on a blank grid. It's a living map where evidence, terrain, and infrastructure come together. This is where we see the culmination of Lecture 9's discussion on digital cadastral systems. In that lecture, we said that every line on a parcel map has both legal meaning and spatial implication. Here, you're visualizing that truth. You can see how a legal boundary exists within a physical environment, how contour, elevation, and infrastructure all inform what's happened on the ground. Back in Lecture 4, when we talked about plats and presentation, I said that every good drafter should aim to communicate the land's story, not just its dimensions. That idea applies here. The combination of evidence, geometry, and topography gives you the full narrative of your parcel, one that future designers or developers can build upon with confidence. And from a professional standpoint, this is where the distinction between a drafting technician and a surveying professional becomes clear. A technician can reproduce a boundary. A surveyor interprets that boundary's relationship to everything around it. Now that your parcel evidence, annotations, and site context are complete, the last step is preparing your final deliverable. The drawing that communicates your work clearly, professionally, and in accordance with survey and drafting standards. This part of the process is all about presentation, not just what you show, but how effectively you show it.
All right, so this is practical exercise 4, preparing for presentation and final deliverables. Go ahead and open your drawing, and the first thing we're going to do is we're going to start a new template or add a new template to our drawing. For this exercise, I'm just going to use the base template that was provided when we installed Civil 3D on our machines. So that's going to be the tutorial-iArch. Go ahead and find that. Go ahead and click open, accept the default layout name, and let's click over to that. So here's our template. First thing we need to do now is get inside of our viewport. We need to activate it. For those of you with GIS experience, the viewport is similar to your map frame. So first thing we got to do is we need to unlock it. So click unlock, then click on it, and then you can double click it. Depending on your settings, it's either going to open this max view or just turn on the frame. Go ahead and zoom to the extent of your drawing once your viewport is active. Let's get relatively centered on that. If you're in the max view, go ahead and under the view drop-down menu, go to viewports and set this to viewport 1. Then you can go ahead and type in VP min, and that's going to close out this maximized view. And then we're going to go ahead and go to viewports, hit viewport 1, and then we're going to drag it to fill the space of our existing frame. So we have that in. Go ahead and double click then inside your drawing, and that's going to activate the viewport. Let's get ourselves relatively centered. Then we need to scale our drawing. So we see 1 inch to 10 feet. That's still a bit small. So I'm going to go ahead and set a custom scale. I'm going to add that. I'm going to do 1 inch equals 8 feet. You can see down here for the scale properties, I'm going to change those drawing units to 8. Hit OK. Now it's listed. I'm going to move it down just so that it's in order because I'm neurotic like that. Click OK again. And it doesn't automatically set it, so I need to go in and now set it to 1 inch equals 8 feet. And I think this is an ideal scale for my drawing right now. I'm going to get it relatively centered just so that I'm happy for it. Hit regen just in case anything needs to repopulate. And then I'm going to go over to geolocation, and I'm going to turn on my map. This is going to add a base map to my drawing. You can use whatever base map you would like. You go through them, see what they look like. You'll notice pretty quickly the imagery is not high resolution, so it's not really ideal. Whatever base map you choose, make sure that you assign appropriate colors to your symbology so that they are going to be appropriately visible in your final plat. If it asks you to sign in at this step, just go ahead and use your TIMUCC credentials just like you did last week. So I'm going to do the Esri light gray base map. And this is where not having that mask on our labels comes into play that we talked about earlier. I'm going to go ahead, lock that viewport. I'm going to click out of it for now. You can see when I try to pan around, it's moving the entire sheet and not specifically the active drawing inside the viewport. So right now, we've got it here. We've got it loaded. What's the first thing we notice? Those labels are impossible to read. So we're going to go through and we are going to update all of our parcel labels to ensure that they're going to be more readable now on our layout. And this should be the final time that we're changing these text sizes, because now at this point, we're actually looking at creating our final product. We're no longer working on our drawing. We're no longer adding features, adjusting line types, or we might adjust line types, but we're not adding anything new here. We're no longer in the design phase. We're clearly in the final phase, and this is our last chance as well for any type of QA QC. So we're going to make any final minute adjustments at this point and ensure that our drawing both represents accurately the data that we collected in the field, as well as any other specific relevant information that our client has requested we include in a final deliverable. So sometimes it's just trial and error to find what's that right height. You'll find out what works best for you. You'll have templates with specific specifications at some point. Like I've said before, just like with line types, colors, symbology, every organization has the potential to have their own unique requirements. So don't take anything that I'm doing right here as gospel, as what you're supposed to be doing. Just go ahead and treat this as what we're doing for this lab. Again, it's more about exploring how to make adjustments, not necessarily these are the ways you should do it every single time. There really is no perfect solution. All right, so I'm trying to adjust my distance and bearing labels. You could see here, I made that adjustment and there was no change. So I'm going to have to go back into the parcel line style. I'm adjusting it, but I'm not seeing any changes. Let me go into the contents. This isn't the right spot. Give me just a moment while I sort this one out. This isn't it. We're not having dragged symbology, so this won't make a difference. I don't know why I changed that. Oh, yes, here we go. Sorry, it's our components. So our bearings are our component 2, and our distance is going to be our component 1. So we can go ahead and adjust our heights under here. So in the label style composer, go into the summary tab, and then adjust those individual components. Hit apply, hit OK, hit OK. Huzzah, we finally got those updated. All right, so now our drawing is looking to be a bit more legible. And another thing to note here, sometimes even the sizes I chose, they might seem a little bit small to you, but do remember that this is going to be a 24 by 36 printout. You're not looking at this in a 100% scale. So this text is going to look a lot larger once you plot it out than it might right now. But what I'm doing right now is I'm adding all of my annotations denoting my easements and my yard restrictions. So again, I went under the Annotate tab and I'm doing multi-liter labeling. You can see here again, once I put in that text, it's looking to be a bit small. So let's go ahead and adjust our text height from 0.18. What's 0.5 look like? That's entirely too small as well. Don't change the rotation. All right, 1.5, that looks a little bit more appropriate. Something else, I'm not seeing the arrow that's supposed to be down there. So I'm going to go ahead, I need to go back into my settings and adjust that. I'm going to define it as annotative. Back into properties. If I could read, this would go faster. All right, and then we can see down here, we can change our arrowhead size underneath the leader. So let's go ahead and make that 0.25. How's that look? That looks good. All right, so what I'm going to do now, instead of redoing those settings each time, I'm just going to copy this annotation over to our other 2 easements. And then I'll adjust the text to match what it is they're specifically supposed to be saying. So this here is our 15-foot utility easement. There we go. And then the other one is that abandoned 20-foot roadway easement. The specifics for that one, again, we were able to see that here in our original subdivision plat. Let's zoom in on that for y'all. And we want to include all of this information. So you'll notice these easements here, they do mark where they're specifically coming from, given that it's an entire subdivision. However, here I think it's a pretty fair implication for people to understand that that distance is going to be from the back of the lot. So let's go ahead and put in all of our specifics. 20-foot roadway easement vacated by city ordinance number, what was it again? 026171. Put that space in there. Now we see our labels are overlapping each other, so we're actually going to need to change um, their attachment style. So right now, it's a left attachment. It's set to middle of top line. Let's go ahead and change that to bottom of bottom line. And then for the 15-foot utility easement, I'm going to change that from middle of top line to top of top line. That'll give just enough separation without having to really adjust the locations of those leader lines as well, because I do like it when they're all identical. Then I'm going to go ahead and add one more multi-leader line, specifically for my overhead power line. So I'm able to actually copy the same one again, and I can drag it to a new direction. And then let's go ahead and identify what that is. Control A, not just A, Control A. Overhead power line. There we go. And if I had the owner information for that power line, I know it is AEC, so that's probably information that I would include in here as well. But then I'm going to change the right attachment style to just do middle of top line. So I could have put overhead power lines, that I could have put the AEC, contact information or permit number for owning and operating that line on this easement. So from here, we have a pretty solid model coming along. We have some couple other corners that we recovered. It's probably not information that I need to include on this final plat. They only need the four corners of their lot denoted. I'm not going to adjust the text height here, but y'all probably will and probably should. You should probably also denote your point of beginning again for this parcel. But again, that's not the point of beginning for the entire survey, but it should be for where we specifically were drawing this parcel. So that I think it was 0.1068. Additionally, we know we need to include a north arrow as well as a scale bar. So under layout, you're able to go ahead and add those different layout elements. You see this tiny little black dot, that is the north arrow. So we're going to have to adjust its properties as well, so that it's not microscopic. So let's go ahead and change the X and Y scale factors. Actually, we can just change the whole north arrow scale factor from 0.1. Let's say 0.5, still tiny. 5 is gigantic. It's the USS Enterprise coming through now. 1.5. That's pretty clean. Again, you don't need a giant north arrow that's going to take over your entire drawing. It can be subtle. Where you want to place it is really up to you. I'm going to keep it on the map frame. Maybe you have somewhere specific within your title block you'd like to have your north arrow and your scale bar. I'm just going to put mine up here for now. Again, these aren't where they should always be. It's just where I'm setting them for the purpose of walking through how to add them. So we've got a north arrow. We've got a scale bar. We've got scale bar settings. I don't know if I like the size of this one. Honestly, I don't like the look of this one. But I'm not going to go back and put a different one in. This is fine. You could see if I change the scale factor, the units, the actual spacing didn't change at all. So whatever that default scale factor is, you need to be very careful about adjusting it because it will skew the information on your scale bar. So go ahead and leave that the same. I want y'all to come through. I need you to annotate and fill out your own title blocks. In Lecture 4, you should have all been quite familiar with specifically how to do that. If it doesn't have automated input areas for it, you're able to go into the Annotate tab and either do single or multi-line text. Go ahead and include that information, clean it up, line it up. Don't have a bunch of just random bits of text thrown all over your drawing. Other things that would be great for you to do in here is maybe do things like include symbology for that power pole, denote the location of the power pole that we did find. I still have the Kogo lines visible on here. You can remove those as well. Once you're done, we're going to plot it. When you hit plot, you're going to get this little pop-up that says your online map will not be printed. So just to make sure that you do have it secured, go and close out your plot option. Go back over to geolocation. Let's adjust our viewport. We're going to hit capture area and hit capture viewport. And once you're done with that, we can go ahead and leave our viewport. So hit VP min again if it opened up max for you. Then you can go back up to the top. Let's go ahead and plot. And you're going to get that same warning. It shows up every time unless you check the do not show me this message again box. But we've captured it, so I feel good about it. Just accept it. We can leave our settings as default. Go ahead and give your final deliverable a name. This is going to be what you submit for this course. So this PDF, this is it. This is your final lab submission. Plot it, pull it up. You'll have one more chance to review it before you submit it after it's been plotted out. I can tell you right now, looking at what I have here, this is subpar work. So this is not the level of quality that I'm expecting from you. I expect it to look a little bit neater. Again, this is the final deliverable, the culmination of everything we have done so far in this course, all brought together at once. So take your time when you're doing this, when you're doing your designing, give it a little bit of extra love. Clean everything up, mark those additional features, remove, things like Kogo lines. Those don't go on our plats. And if you have questions, again, feel free to email me. But other than that, congratulations on completing the final lab of this course.
This validation process represents the critical quality control step of any professional mapping or surveying workflow. Back in Lecture 5, when we discussed boundary conflicts and case law, we learned that discrepancies between record evidence and field conditions often lead to disputes. In a digital context, discrepancies between CAD parcels and Kogo reconstructions can lead to similar confusion, especially if a client or engineer assumes that digital equals precise. By measuring, comparing, and documenting those differences, you're ensuring transparency and defensibility. That's what distinguishes a CAD tech who merely traces lines from a survey drafter who understands the meaning and context of boundaries. In Lecture 7, we discussed how engineering design and surveying workflows overlap, how surveyors must sometimes enter the design space to understand the broader context of their work. This export step does exactly that. You're packaging evidence into a design-ready format so that in our future lectures or your future projects, you can integrate it into Civil 3D, label it with real-world stationing, and see how survey data supports the foundation of every engineered project. As we bring this final lecture to a close, take a moment to look back on the path you've taken, not just in this project, but across the entire course. You began in Lecture 1 by learning where this profession came from, how surveying shaped civilizations, nations, and boundaries. You studied the work of those who mastered the land long before you, and how their legacies continue through the laws, systems, and technologies we use today. From there, you built layer upon layer of understanding. In lectures 2 through 4, you learned how surveying connects to drafting, design, and representation. You explored how lines, angles, and measurements evolve into maps, plats, and plans, the essential language of land documentation. By Lecture 5, you stepped into the legal side of our profession, studying the hierarchy of evidence and landmark cases like Stafford v. King, Hicks v. Lovelace, which taught us that surveying isn't just measurement, it's interpretation of law and history. And as the semester progressed, Lectures 6 and 7 pushed you deeper into practical and technological applications. Site surveys, Civil 3D, GIS, construction, and the shared responsibilities of engineers and surveyors. Those lectures bridged your understanding from evidence to execution, from the surveyor's field notes to the engineer's design model. Lecture 9 expanded your view even further, connecting your work to larger digital systems like central appraisal districts, cadastral mapping, and GIS-based record keeping. Then came Lecture 10, where everything became tangible. You'll learn to locate courthouse evidence, retrieve CAD parcel data, and build a boundary sketch inside of ArcGIS Pro. And today, in Lecture 11, you've completed that journey, bringing your verified evidence into Civil 3D, refining it, and representing it as a professional deliverable. This final project represents the true intersection of surveying's past, present, and future. You started with written descriptions, the legal language of land. You then worked through digital systems, the modern tools of analysis and visualization, and you ended with a professional product, a boundary exhibit that could stand as part of a real world survey or engineering project. More importantly, you've experienced what it means to think like a surveyor, to weigh evidence, to question assumptions, to integrate systems, and to communicate results with integrity. That mindset, not the software, not the hardware, is what defines our profession. As you move beyond this course, remember that each new project begins where this one ends, with evidence, judgment, and the responsibility to represent land truthfully. Technology will continue to evolve. New GIS tools, new AI assisted drafting systems, new ways of visualizing spatial data, but the surveyor's core mission will never change. It is, as it always has been, to establish and preserve the truth of the boundary. So take pride in the skills you've developed in this course and recognize how far you've come since you started. You've learned to bridge centuries of practice, from courthouse ink to digital coordinates, from legal records to 3D surfaces, from the page to the field. That's what it means to be a professional in this field. Congratulations on reaching this point in the course, and welcome to the next step of your journey as a future surveyor.